Today we're learning about operations with complex numbers. Complex numbers are numbers that you've gotten by taking the square root of a negative number. Remember, it has a real part and an imaginary part, like 3 plus 3i. Okay? So we're going to do operations. We're going to graph, find the absolute value, and add and subtract. First of all, with graphing, all you have to do is remember that the real axis is the x-axis. And the imaginary axis, the I part, is the y-axis. So if you think to yourself, a plus bi is now x plus yi. I've written out an axis right here. The real numbers are the x, the imaginary numbers are the y. And where it used to be just -1, -2, -3, it's now -1i, -2i, -3i. Okay, let's try 4 examples. Graph each complex number. I have the plane right here. -2 minus 3i. So if I come over here, we always start at the origin. I'm going to go +2, -1, 2, 3i. And there's A. B, -1 plus 4i. -1, 1, 2, 3, 4i. C, 4 plus I. 1, 2, 3, 4, 1. And D, -i. It really is that straightforward. Okay, absolute value. Remember, absolute value of a real number is its distance from 0. Now, the absolute value of an imaginary number is its distance from 0 along the imaginary axis. So it's a little different, where the real number was just the number line. So if we had the absolute value of -3, the distance -3 is from 0 is 3 units. So the absolute value is 3. 3 plus 4i. Okay, we just graphed that. We went over 3, up 4. That is the point. So 3 plus 4i is the distance from the origin. Pythagorean theorem tells us a squared plus b squared equals c squared. So we do a squared plus b squared equals what this measurement is. 9 plus 16 is 25, so our absolute value is 5. Let's try a few examples. Find each absolute value. Start out with this one. We just take the square of the real part, the square of the imaginary part, add them together. 9 plus 25 is 34. We can't simplify that any further, so that is our answer. Square root of 13. Okay? Square root of the absolute value of -13. If we wrote it in complex parts, our real part, our imaginary part. Okay, -13 squared is 169. Take the square root of 13. That makes sense because that's just a real number. The absolute value of -13 is the distance from 0, which is 13. Let's try one more. -7i, the real part plus the imaginary part. The real part squared, the imaginary part squared. -7 squared is 49. We have our answer. Very straightforward. Our last example, adding and subtracting. Adding and subtracting complex numbers is very similar to adding and subtracting variable expressions, where we just collect our like terms. Here we're collecting like terms, we're combining the real parts and the imaginary parts. So real parts and imaginary parts are our like terms. Example, 4 plus 2i, that's a complex number, plus -6 minus 7i, that's a complex number. We look for our real parts, written right there, and our imaginary parts, written right there. And we have our answer. 4 minus 6 is -2, 2 minus 7 is -5. 3 more. Okay, collect your like terms. Our real parts, our imaginary parts. We have our answer. With subtraction, it gets just a tad bit more complicated because you have a negative that you need to distribute through the second set of parentheses. That negative I need to distribute. So negative negative is positive 2, negative negative is positive 3. Then we just collect our like terms. Real parts will give us, real parts will give us 5 plus 2 is 7. Imaginary parts, negative 2 and 3 is positive 1, which is just I. Last example. Okay, collect your real parts. 1 minus 1 is 0, and your imaginary parts. Negative 3i, positive 3i is 0. So you can actually have 0 for an answer. That's all we have for today.